Hello everyone from Legal Hacks team. Good morning, evening, afternoon, or whenever time you're watching this from. We are the Proofly team. Abdurrahman Ahmed, Muhammad Salim, Fadi Ahmed, and Salah Shalabi. Our project is called Proofly, Decentralized Employment Verification. The idea is very simple. We use blockchain to help companies and employees prove real work relationships fast, secure, and trusted. With Proofly, anyone can check if a person really worked for a company in seconds, not weeks. And here we have our GitHub repository, which is open source, of course. Our entire code base is open source because we believe in transparency. And we have our website or live demo. This is how the website looks on the very overlay layer, and we can have a full walkthrough in detail about the entire system later. So, what seems to be the problem? The problem with today's employment verification cycle that it's most likely broken, slow, hard, and full scams. People fake a lot of jobs on LinkedIn, and many companies lose money and trust. Over about 3.9 billions are lost every year in job scams. There's no easy, global, trusted way to verify who really worked where. So the employment world is really in pain. Almost 68% of job seekers see fake recruiters or ghost jobs. Fake companies steal data or even money, and real companies get blamed for these scams that they didn't make. People cannot provide the real work, history quality, and that hurts the trustworthy of the companies. So our vision is Proofly works like a digital notary for employment. It gives instant, cryptographically secure proof that someone is or was employed by a certain company. It's private, fast, and easy to check. It can help embassies, courts, companies, and job platforms. So, how exactly this Proofly works? First off, a company registers on Proofly. The company admin adds a company. An employee can generate a unique proof code. Anyone in the world can verify that code online. No login needed, like an anonymous verification. So no paper, no long process, just a quick cryptographic check. So why exactly RCB for this legal verification? Well, for a lot of reasons. Tamper-proof records, cryptographic authenticity, full decentralization, privacy by the design, legal grade verification, cost efficient, user friendly, and last but not least, easy authentication with internet identity, V2. Which takes us to our system architecture. On the front-end layer, we use Next.js and TypeScript. For the backend, we use Rust, and the storage, we used stable memory for data persistence. So here, in our system architecture, we have, firstly, the company as admin. A company logs in via Internet Identity V2. And now, the admin can do a whole lot of acts. Mainly, register a company and manage the employee. So, the admin can register a company, add employee, and set positions to those employees. And he also can remove those employees, which takes us to the employee entity. After the employee logs in as well via Internet Identity V2, he selects the company that he works for. And when he selects the company he works for, he's automatically authenticated because the company admin registers this employee. If not, then this is not an employee of this company. After that, after the employee is created, authenticated, and selected the company that he works for, he requests a proof from our system, and our system responds with a proof, a generated code that's valid for about 24 hours. And you can verify that via a third-party verifier or a third-party library, no login required, and it's also public accessed. So, the smart contract data maps we have a company, employee, proof, and relationships between those three. Here, as you can see, first off, we have the employee entity, which is uniquely identified by its employee ID or the principal ID, as we will see. It has also a full name, which is convenient. And this employee, as you can see in the relation, works at a company. The company is uniquely identified by its username. It also has a name, an admin ID, created at time, and is active. This company, or the admin of the company to be precise, manage those employees with all those positions, as you can see. So the company manages a lot of employees, and each employee works at a certain company, and each employee has a position at this certain company, which takes us to the other relationship between the employee and the proof. Each employee generates a proof, and this proof is uniquely identified by its proof ID and then its generated code. It has a company name, a company username for the company the employee generated from. So the employee works for a company and he generates a proof. This code has the company username that the employee works on. The proof has an employee ID, the position of the employee, created at, expires at, and is used. Which takes us to the proof generation process. So, the proof generation process goes like this. Employee select company. The employee choose the specific company that they work for. System generates random text. It creates a random 10-character string. For example, IEG, etc. at the end. It's randomly generated. Then our system combines text with an ID. For example, 23 at the end of it. System return clear text. The combined text is sent back to the employee, which is his uniquely generated code or proof generated, and the system stores it in the hash. The system calculates and stores the SHA 256 hash of the text. As you can see, we can have a walkthrough in our Rust code base about the generating proof. First, we take our company username and we take the principal and the user ID. We check if user ID works in the company or not. We get the employee position in this company. Then we generate random code of 10 characters first, which is this step. And then we get the next proof ID stable memory. Then the proof is generated, the entire proof, which is the generated code plus the proof ID, the 10 characters plus the unique ID. Then we hash the proof with SHA 256 and we store the hash code in the proof map. And then we return the clear proof code to the caller. And that's for generation process. Proof verification process. First off, the verifier enters the code into the system. Then the system cut the string after the 10th character to get the proof ID, as we explained. Then the system gets the proof stored in the memory and checked if the proof is already used or expired. If it's expired or already used, it like closes off. It's like returns. This is not a valid proof. And if it's a valid proof, the system compares the hash of the input and the hash of the memory. If the hash matches, the proof is marked as used. So you cannot use it again after that. The system provides the employee data if the proof is valid. If hashes does not match, a mismatch message is displayed and we can have a clear walkthrough about this in our code base. Verify proof, as you can see here. So first off, we get the proof code. Then we get the second part, which is the ID. And then we firstly check if the proof is expired, as you can see here. We get the hash of the proof, the real hash of the proof, and we compare that value in the proof that was inputted by the user. We check if the proof is already used, and if it's already used, we display an error which said proof already used. And if it's not the same hash, we display proof mismatch. And if it's not any of those edge cases and it's a valid proof, then we get the company name from the map ID, the company information, and the employee information as well, and we return the proof result with the complete information. That's for our code base. Then we have the live demo and code review. We walk through the code. Let's have some more fun and work through the live demo. Here we can continue, log in. So I'm logged in, I'm redirected to the dashboard, and here I can set my name to start with. So let's add my name, Salah. Sorry. And we save. And of course I have a unique principal ID that is mine, so we can copy that and use it later. And it's just saving my name. Yeah, as you can see, my connection is probably a little slow. And we head to the company management. We can, for example, add a company. So let's call it what? Legal hacks, for example, and company username, legal hacks. You can add this company. And the company is successfully added. We can view this company as the admin, of course, and here I can start adding my employees. So for example, I can add myself. So as you remember, we have the principal ID for adding me, myself, but every employee should have its own principal ID. My position, let's say that I'm the CEO, why not? So here, Salah Shalabi, CEO. Let's add another employee. For example, that's this employee's principal ID, and his position is H, for example. We can add as many employees as we want, not as we want. We can add as many employees as long as they are working on our company and is legally authorized and authenticated. For example, like senior SWE, for example. And here we can, for example, filter our employees by their position. We can like hide or display the columns we want to see. So for example, the principal ID is a little bit messy, so I hide that. And if the employee does not have a default name or username, the principal ID is displayed as a username. That's for note. We can select, for example, we can search, I believe, CEO, they display me. We can select a lot of codes, we can delete them. For example, let's delete day 2. I fired these 2 people. Goodbye. Yeah, that's it. I can also edit. So I got demoted. I'm unfortunately, to CTO. Updated successfully, and now I'm officially demoted. So that's fun. Let's try generating a code. So as we explained, I'm generating the proof. So first, as an employee, I select the company that I work for. Then I generate the proof for this company. And then I copy the proof. Then I go to verify that proof. Hooray! Proof code verified. So what happens if I try to verify my code again? Verify failed. Proof already used. That's unfortunate. What if I entered something invalid? Invalid proof ID. Something a little short. Proof code must be at least 11 characters long, which is 10 random characters and the ID, as we explained. So yeah, that's most likely it for the process, but let's try something more fun. Let's generate another proof here, and let's actually log out. So now I'm no longer logged in as Salah Shalabi, as owner of the company I created, which is Legal Hacks. So I have the code, and I can try and verify this code. So I can actually verify codes of the employees or of the companies as an anonymous user. So I do not need to be logged in, or I do not to be like a CEO of any company. I can anonymously go into Proofly and verify the code. And hooray, proof code verified. And look at this. When the code is verified, it gives us the company name, the position name, the employee name, and the created time of this code. So yeah, that's about it for our walkthrough. We can walk more into details, but that's about the main walkthrough or the flow of the generation process and verification process, which is our main goal of this project here. So for our future business model, and why companies will join Proofly as a SaaS, software as a service. Companies can subscribe to us to protect employees from impersonation, enable employees to prove employment easily, not through old paperwork and stuff that takes a lot of weeks, strengthen brand trust, reduce legal verification costs. Future models: low-cost monthly subscription, proof API integration with the HR system, verified partner badge for LinkedIn. And here we have a lot of references, resources, and discussions from all over the internet: LinkedIn, Reddit, CIO, Jobs.io, LinkedIn News, about this job scan or about this problem we discussed earlier in the presentation. And the fun part is the journey is just starting. This is the only first milestone we're building. We aim for more upcoming features and more growth and more milestones. We dream of LinkedIn integration, digital signature proofs, company level analytics, multi-language, and mobile apps. And lastly, thank you very much for listening. This was Proofly, built on ICB from the Legal Hacks 2025 team. Check our demo and GitHub and feel free to reach out. Trust, privacy proof, and that's Proofly.